Okay, children. Today I will explain the problem section of work energy and power. So let us see this example 6.1. Find the angle between the force vector F equal to 3i cap plus 4j cap minus 5k cap unit and displacement vector D equal to 5i cap plus 4j cap plus 3k cap unit. Also find the projection of F on D. So here two vectors are force and displacement vectors are given. And find the angle between the force and displacement. So what is the relation connecting them? Force, displacement and angle. That is work done equal to Fd cos theta. Fd cos work done equal to Fd cos theta. Fd cos theta means F dot D. So F dot D equal to Fd cos theta. Therefore cos theta equal to F dot D by Fd. So first you have to find F dot D. This is vector D. What is F dot D? And we have studied the formula. See, A dot B equal to Ax bx plus Ay by plus Az bz. Just like that. Fx dx plus Fy dy plus Fz dz. That formula we have to use. So Fx is 3. Dx is 5. So 3 into 5 plus 4 into 4 plus minus 5 into 3. That is Fz dz minus 5 into 3. So 3 into 5, 15. 4 into 4, 16 plus minus 15. Minus 15 and plus 15 cancel. We get 16. And we write the unit. Unit here also unit is there. So you can also write the unit. Okay, F dot D 16 unit. Find vector F dot D. That is equal to Fd cos theta equal to 16 unit. We got that. Then we have to find F and D. See, F dot D we got 16. But F and D, how will you find? Vector F is given here. How will you find its magnitude? Here simply if we write F, that means its magnitude. So how will you find magnitude? Magnitude of F is root of, see this is A square, A dot A, Ax, Ay plus Az. So A square, A dot A is A square. A dot A square, have you got? A into cos 0. Same vectors, angle between the same vectors is 0. Similar vector. So A dot A equal to 1 into cos 0. A into cos 0. For unit vector, 1. Here A is the magnitude. So A into cos 0. A square. So A square is X. A square. You see the formula? A square. X square plus Ay square plus Az square. So what is A? Root of Ax square plus Ay square plus Az square. So we can see F dot F. Fx square plus Fy square plus Fz square. What is Fx? 3. 3 square plus 4 square plus minus 5 whole square. Minus 5 whole square is 25. 3 square is 9. 4 square is 16. So 9 plus 16 plus 25. So we get 50 unit. Similarly, D dot D. D dot D. So dx square plus dy square plus dz square. 5 square plus 4 square plus 3 square. That also we got 25 plus 16 plus 9 equal to 50 units. So we got F, we got D also we got. So we can substitute in the formula cos theta equal to 16 by root 50 into root 50. So equal to 16 by 50 equal to 0.32. Got the N from log table. Log table, that is which page? Natural logarithm page. Natural cosine you have to take. From that, from 0.32 what is the corresponding angle? You have to find out. So I have explained to you that before, and from that you have to find out which angle. What is angle corresponding to cos theta equal to 0.32. Therefore, theta equal to cos inverse 0.32. What is that angle? That you have to find out from log table. And when you call me, you have to tell the answer. Okay, point corresponding to 0.32. What is the angle? Next page we can see. Next. See, consider a drop of mass 1 gram falling from a height 1 kilometer. It hits the ground with a speed of 50 meter per second. What is the work done by the gravitational force? What is the work done by the unknown resistive force? So here about a raindrop, it is telling a mass of the raindrop equal to m equal to 1 gram only, change into kilogram. Gram, how will you change into kilogram? Into 10 raised to minus 3. So 1 gram equal to 10 raised to minus 3 kilogram. Height from what height it is falling? 1 kilometer. So that is in SI system, no need to change. It hits the ground with a speed of 50 meter per second. So just before it hit the ground, its speed is 50. So final velocity is this, 50 meter per second. What is the work done by the gravitational force? So we know the raindrop is falling because of the gravitational force. Earth attract all bodies towards its center. So gravitational force it is falling. So work done. We know when a body is at a height, which energy it possesses? Potential energy. What is the equation for potential energy? mgh. So what is the work done? That you have to calculate work done by gravitational force. That is mgh. Work done by gravitational force is mgh. So m is 10 raised to minus 3. G is equal to, here G is taken as 10 into height. We know 1 kilometer change into meter SI system. Kilometer 10 raised to 3. So 10 raised to minus 3, 10 raised to 3, that will get cancelled. Then 10 remains. So 10 joule is the work done by gravitational force. Then change in kinetic energy. See, initially just, at the topmost point, raindrop is having initial velocity 0. Just before it hit the ground, it attains this velocity. We know every body, when it falls downwards, velocity increases due to gravitational force. So final change in kinetic energy means final kinetic energy minus initial kinetic energy. What is final kinetic energy? Half mv square. Minus initial kinetic energy, it is 0 because the topmost point raindrop is having 0 velocity. Then it is falling downwards. So initial velocity is 0. So half into m 10 raised to minus 3 into v velocity 50 square. That is the final velocity. Minus 0. Initial velocity is 0. So what is the change in kinetic energy? 1.25 joules. Change in kinetic energy. And we have studied the work energy theorem. Change in kinetic energy is equal to work done. So here, work done by gravitational force we got. Next, what is the work done by the unknown resistive force? So when a raindrop falls downwards, which is the resistive force? Air resistance. So any body, when it falls downwards, air resistance will be there. So that air resistance we have to calculate. How will you calculate that? Work done by gravity is 10 joule. And the change in kinetic energy is 1.25 joule. So when the work energy theorem, change in kinetic energy is the total work done. Here not only the gravitational force is doing work, but this air is doing a resistive, applying a resistive force. That means negative work is done by the air. Air resistance is there. So sum of gravitational force plus work done by the resistive force of air. That together is the change in kinetic energy. So we can apply that WR from that resistive force, work done by the resistive force equal to change in kinetic energy minus work done by gravity. Change in kinetic energy we have delta K we have already calculated 1.25 joule. So 1.25 minus 10 by gravitational force. So minus 8.75, and it is negative because it is the work done by resistive force, opposing force. That's why it is negative. Next, you can see this example. A cyclist comes to a skidding stop in 10 meters. During this process, the net force on the cycle due to the road is 200 Newton. So you can write the cyclist come to a skidding stop. So distance traveled after applying the brake, it traveled 10 meter distance. So this displacement you can write 10 meter. And the force on the cycle during this process, the force on the cycle due to the road. So road exert a force on the cycle, and that's why it stopped. So that's equal to opposing force as exerted, and that's 200 Newton. Force exerted by the road on the bicycle, that's equal to 200 Newton. Yes, and because of that, the cycle stopped. How much work does the rod do on the cycle? Work done is equal to F d cos theta. Work done is equal to F d cos theta. The stopping force and the displacement make an angle 180 degree, pi radian with each other. That's work done by the rod equal to F d cos theta. So F is equal to 200, D is equal to 10 meter, cos theta. Cos theta equal to pi. Do you know how we got this pi? The stopping force and the displacement make an angle 180 degree with each other. That means cyclist is moving forward and the road is exerting an opposing force, that is backward. So what is the angle between the cyclist moving forward? Road apply force, that means the frictional force, that is opposite to that and tangential to it. So what is the angle between them? One forward, other is acting opposite to that, backward. What is the angle? 180 degree. That is 180 degrees the angle. So we have to substitute theta as pi. So 200 into 10 into cos pi. Cos 180 is minus 1. So what's the answer? Minus 2000 joule. Okay. Minus 2000 joule. It is this negative work that brings the cycle to a halt in accordance with the work energy theorem. From Newton's third law. Then next question. How much work does the cycle do on the road? How much work does the cycle do on the road? We know, according to Newton's third law, for every force there is an equal and opposite reaction. So, road do minus 2000 joule of work on cycle, work done, because there is displacement. Even though road exerts an opposing force, the cyclist moved the distance of 10 meters. So work done is there, F d cos theta. But you know that cyclist also do apply a force on the road. Equal and opposite force cyclists exert on the road. But you know, there is no displacement to the rod. The rod remains there itself. No displacement to the rod. Therefore, work done is 0 because there is no displacement to the rod. So work done by the cyclist on the rod is 0. There is no displacement to the rod itself. Next, another example. These are all textbook questions. In a ballistic demonstration, a police officer fires a bullet of mass 50 gram with speed 200 meter per second. So mass is given in gram, you have to convert into kilogram. 15 to the raised to minus 3 kilogram. And speed is given in SI system, meter per second. Speed, velocity is given 200 meter per second. Then that is the initial velocity of the bullet. Then on soft plywood of thickness 2 centimeter. Ballistic demonstration, a police officer fires a bullet of mass. Bullet's mass is given with a speed of 200 meter per second on soft plywood. So fires onto a soft plywood. Okay, and its thickness is given 2 centimeter. The bullet emerges, so it is crossing that plywood. 2 centimeter only thickness. So distance you can take 2 centimeter. Centimeter you have to convert into meter. The bullet emerges with 10% of its initial kinetic energy. So initially, what is the kinetic energy? Mass is given, velocity is given. So you can find out the initial kinetic energy, half mv square, half mv square. Kinetic energy half mv square. So that is calculated. Half mv square is calculated using this formula. Mv half mv square equal to half m into m at 15 to the raised to minus 3 into v square. V square is 200 square. So when you calculate, you will get the answer 1000 joule. So initial kinetic energy of the bullet is 1000 joule. And when it emerges out of the plywood, we know when it passes through the plywood, what happens? Velocity decreases. So kinetic energy decreases, and finally 10% of its initial kinetic energy only it is there. Initial value is this. What is the 10% of that into 10 by 100? So that will be 100 joule. So into 10 by 100 you have to do for finding what? Emerging energy. After passing through the plywood, it emerges out. And what is its energy? 100 joule. This into 10 by 100. So 100 joule. If Vf is the emerging speed of the bullet, we can write half m Vf square equal to 100. Emerging energy is this much only, half m Vf square. And what is the question? What is the emergent speed of the bullet? So this speed, Vf final speed, we have to find out after emerging through the plywood. What is the velocity? So Vf is equal to square root of 2 into 100 by 0.05 kilogram. That is equal to 63.2 meter per second. When we find the square root of this, you get this answer 63.2. You can use that long division method for finding the square root. 63.2 meter per second. Okay. Next. To stimulate car accidents, auto manufacturers study the collisions of moving cars with mounted springs of different spring constants. Consider a typical simulation with a car of mass 1000 kg moving with a speed of 18 km per hour on a smooth road and colliding with a horizontally mounted spring of spring constant 6.25 into 10 raised to 3 Newton per meter. What is the maximum compression of the spring? So you have to consider a car of mass. Mass is given in kilogram. We know SI system, kilogram is the mass. So you have to just write m equal to 2000 kilogram. Speed. So initial velocity equal to 18 kilometer per hour, change into meter per second. Because SI system, it is meter per second. So what to do? Into 5 by 18. So we get into 5 by 18, what we get? 18, 18 get cancelled, 5 we get. 5 meter per second is the speed. Then on a smooth road and colliding horizontally with a horizontally mounted spring. So it is colliding on a spring, and spring constant K is given 6.25 into 10 raised to 3 Newton per meter. What is the maximum compression of the spring? Work done. We have to calculate. So kinetic energy of the moving car. Actually, that energy is converted into compress the spring. That much energy is used to compress the spring. So kinetic energy is equal to half mv square, half into m, 1000 kg, 10 raised to 3 kilogram into v. V is, I told you, 18 kilometer per hour. You have to convert into meter per second. How? Into 5 by 18. So 18 cancel, we get 5. So 5 square. So kinetic energy we got 1.25 into 10 raised to 4 joules. There we have converted 18 kilometer per hour into meter per second. Yes. Then see the potential energy V of the spring. So kinetic energy of the car is compressing the spring. So when the spring is compressed, what energy it is having? Potential energy. Compressing, stretching of a spring. When we stretch, we are doing work to stretch it. That energy will be stored in the spring as potential energy. Similarly, when we compress the spring, energy will be stored in that. We are doing work to compress it. So that energy will be stored in it as potential energy. Similarly, the moving car is compressing the spring. So potential energy will be stored in it. So that is equation half kx square we have studied. So it is compressed to the maximum level. So that's why we have taken m here maximum. X m half kx square. So that is calculated half kx square. K value is given. Distance is also given. So distance is not given. From that formula, you calculate xm. See, half kx square equal to this energy. This energy you have to give here. Kinetic energy is converted into potential energy. Then xm is the only unknown quantity. K is given here. Xm is the only xm square you will get, and from that you have to find out the xm. Xm square will be 4, and xm will be root of 4. That's 2 meter. All of you have to do the calculations in your notebook and show me when you solve. Okay. I want to check whether you are studying it or not. That's why I ask you to follow every week. And this conversion I will show you. See, 1 kilowatt hour. How much energy it is? 1 kilowatt hour. Kilowatt hour is commercial unit of electrical energy. And how will you convert into joule? Joule is just a unit of energy. So everybody should know kilowatt hour. How will you convert that into joules? So 1 kilowatt hour. 1 kilowatt is 1000 watt. Hour. 1 kilowatt hour. Yes. Hour. So we can write 1000 watt into 1 hour. How many seconds? 3600 seconds. So kilowatt hour. 1 kilowatt is 1000 watt. 10 raised to 3 watt. Into 1 hour is 3600 seconds. So this we converted into SI system, kilowatt, and hour we have converted into seconds, SI system. So now the units are in SI system, watt second, and that is joule. So 3.6 raised to 6 joules. So that is the unit of SI unit of energy. That means in joule. Kilowatt hour is changed into joule. You have to remember this conversion. 1 kilowatt hour is 3.6 Newton raised to 6 joules. Next, an elevator can carry a maximum load of 1,800 kilograms. A lift can carry a load of 1,800 kilograms. That is elevator plus passengers. The elevator plus passengers weight is 1,800 kilograms. Is moving up with a constant speed 2 meters per second. So lift is moving with a speed of 2 meters per second. Speed of the lift is 1. The frictional force opposing the motion, we know air of will oppose this motion, and the frictional force opposing the motion is 4000 Newton. So we can write frictional force opposing is 4000 Newton. Determine the minimum power delivered by the motor to the elevator. Power delivered by the motor to the elevator. So against the frictional force, the motor has to do work to lift, to move it upwards. So that power you have to find out in watts as well as in horsepower. So in watts and horsepower you have to find out. The downward force on the elevator, see, that is equal to mg. Mg is the force due to gravity, total mass of the body into gravity, that is the weight of the body, and against the frictional force also the motor has to do work against the frictional force also. So you have to add that also. Frictional force is given, opposing motion. So against that the motor has to do work to lift the elevator upwards. So that also we have to add. So mg plus F frictional force. So 22,000 Newton. That is the force. The motor must supply enough power to balance this force. Hence, power equal to F dot V. We have studied one formula, power equal to F dot V. So F we have calculated 22,000 into velocity is equal to 2g1. So instantaneous power P equal to F dot P. And that we got in an answer in watts. And how will we convert in horsepower? 746 watts is 1 horsepower. 746 watts. So 44,000 watts, how many horsepower? Divided by 746. This divided by 746. That will give 15 horsepower. So you should remember that relation. 1 horsepower is equal to 746 watts. Next. Okay, next question. A woman pushes a trunk on a railway platform which has a rough surface. She applies a force of 100 Newton over a distance of 10 meters. Thereafter, she gets progressively tired and her applied force reduces linearly with the distance to 50 Newton. The total distance through which the trunk has been moved is 20 meters. Plot the force applied by the woman and the frictional force. You have to plot the graph, which is 50 Newton versus displacement. Frictional force is 50 Newton over a displacement or the total displacement. Calculate the work done by the two forces over 20 meter. Work done by the two forces. One is frictional force, other is the force applied by the woman. By over 20 meter, both that work done we have to calculate. So first you have to plot the graph. See, a woman pushes a trunk on a railway platform which has a rough surface. She applies a force of 100 Newton over a distance of 10 meters. So that part we can draw. 100 Newton over a distance of 10 meters. So first you can mark 50 Newton also is coming. So you can mark 50 here, then 100 here. So 100 Newton she offers for a distance of 10 meters. So 10 meter, 20 meter. Two distances are coming here, 10 meter and 20 meter. Up to 10 meter, she applies a force of 100 meter. So this graph BC represents that. We can draw a straight line. Up to this represents 100 Newton force is applied over a displacement of 10 meters. Then she gets progressively tired after applying 100 Newton force for a distance of 10 meters. She is tired. And what she do? Reduces her force. Applied force reduces linearly with the distance of 50 Newton. Linearly, her force is reduced. She gets progressively tired and her applied force reduces linearly with distance to 50 Newton. Up to 50 Newton, that force gets reduced. So this is 50 Newton. So here we can see that force is reduced. Force is reduced. No? So here up to 50 Newton it is reduced. Okay, 50 is 50. So you have to draw mark a point here, and that linear reach is reduced, decreases. Force is reduced. So this is the part of that graph. Okay, CE is the part of the graph. And here what you can see, this we have drawn the graph up for the first part. Understand? Then next, the frictional force is 50 Newton. So we have to mark it downwards because that is an opposite force. This is applied force, but this is opposing force. So for a minus 50, you have to mark downwards, negative force. and up to 20 meter it will be there. Throughout its motion, frictional force will be there. Whether she is moving towards 10 meter or 20 meter, that force will be there. So up to 20 meter, she applies, she will have that frictional force opposite to her force, opposing force. So minus 50 you have to mark here, and the dotted line is marked here up to 20 meter. Throughout its motion, that frictional force is there. Okay. Then the work done by the woman is, we have already derived that derivation. Work done by the graph gives the area under the graph gives the work done. So because this is a rectangle up to 10 meter, what is the work done? How will you calculate the area under this graph? And what is the work done during the next 10 meter? That will be given by the area under this graph. Listen, work done by woman is area of the rectangle ABCD, area of the rectangle ABCD, plus area of the trapezium CEID, trapezium, CEID. So if you find both the area, you will get the work done by the woman. That will be positive. So we work in rectangle. What is the area? Area of the rectangle, length into breadth, 10 into 100. 100 into 10 plus trapezium, half into B1 plus B2 into height. So here B1, what is this? 100, and this one 50. 100 plus 50 into this distance. The distance is 10 meter. 100 plus 50 into 10. So 100 into 10 will be 1000 plus 750. You get 1750. That is the work done by the woman. And work done by the frictional force, area of the rectangle AGHI. AGHI. This is the work done by the frictional force, and it will be negative. Area under this graph. Upper part area is taken positive, lower part we have to take negative. Because we have to take the upper side positive, lower side negative. Area of the rectangle AGHI. Area of the, and this is 50 minus 50, and this is 20. So minus 50 into 20, that is minus 1000 joule. The area on the negative side of the force axis has negative side. That's why we got negative side graph.